This is the organization that has charter members across government agencies and representatives that get together and we basically discuss on behalf of our agencies what's going on within AI and all the different avenues and all the different perspectives that are going on, and then plan together as the federal government as far as how we can advance artificial intelligence. Now, from that perspective, again, we see all of these things happening, but so many times the dialogue, what's being talked publicly, doesn't really fit the reality of the robust level of engagement and investment that's already there. And so one of the things, and again, so these are very brave people up here, and I'm gonna explain, because one of the things, especially GSA, we know that this is an open space right now. And oftentimes, the solutions that we're going to want to move into could even come from organizations that have never worked with government yet. That's why it's critical and important that organizations like ACT-IACT not only have events like this, but also continuously are bringing in the fresh ideas and people to benefit both industry and government agencies so we can start building that future together. So part of that, and we wanted to make sure that today, because it's, hopefully you're all hepped up on coffee by now. You got here early in the morning. We said we wanted to make this event one of the most lively and engaging AI events you can go to, because sometimes AI events are really boring. And then people will also ask things, well, when does it stop being an algorithm and start being a human? To which we always say, we reference the movie Short Circuit. There was a robot, and when it was struck by lightning, that's when God gave it a soul. That's generally how AI events go on for the federal government. So again, we wanted to be lively. We wanted to show these new voices. So these people up here, how many people whose primary job is just AI and leading up for your organization? All right, we've got one. The rest of them, what we asked and we sent, that if you were participating and you were coming to this event, we wanted to open the door and to be able to say, what if you had all these people from the government, from industry, leaders like Intel here, IBM, and you had 5-6 minutes, not to even talk specifically about what you're doing, but what are the things, if you had the stage at the ACT-IACT Artificial Intelligence Forum, what did you want people to know? What did you want people to think about? What kind of hell did you want to raise? And have that conversation be part of the narrative going forward. These people stepped up. So what we're going to do is we're going to go through lightning round sessions. They're going to, whether it's a pitch, whether it's a showcase, whether it's a provocative idea, whether it's reinforcement of what we already know and are championing, they're going to get up here and bear it all. And then we're going to ask questions and we're going to talk about this. And again, this is a diverse representation of people who volunteered, and so it's coming from all different perspectives on this. So that being said, the first up, and does everyone understand the ground rules here? So when we get to the questions and answers too, take it a little bit easy on them. But that being said, don't. Make it interesting here, because hopefully this is kind of setting the standard for the lively participation we can expect. So first off, we have Reva Solutions. Naveen, is he here? No. But you guys didn't sit in that chair originally.
AI didn't compute and we know how to fit two people in.
All right. How many people know Reva Solutions? You're about to know them differently.
So I was going to talk about Skynet for a while. I had a presentation ready, but Justin kind of killed that. So one of the things that...
I killed Skynet?
Well, that's 300 years in the future, but we'll talk about that after this. So one of the things that we at Reva Solutions, where, my name is Raj Dasgupta, I'm the CTO. I've got Roseanne here as well. And we're an 8A firm focused on kind of cutting edge technology, cloud, emerging technologies like AI. So, approximately a year ago, my CEO said, go find the 2 or 3 best AI companies we can partner with in terms of customer service. How do we build chatbots and that sort of thing. So I did, some research, and what I found was there wasn't 2 or 3. There was literally, 200 or 300. This is just for chatbots, in the U.S. that are just focused on customer service. So the field is huge. In the last 12 months, they've been about 18 billion dollars of investment. In the last 60 days, 1.5 across kind of all genres of AI. Our friends at Intel, obviously, they've got a fund investing a lot of money. And what we found is that it's not going to be like cloud where you're going to have 2 or 3 or 4 predominant players. You're really going to have the infrastructure players like the Intels or NVIDIA, IBM with Watson, and then you're going to have an ecosystem of thousands of companies that are very focused on solving very specific problems. So on customer service, that was one of the things that we looked at, and we saw that, hey, there's a lot of companies that are focused on solving retail customer service issues or manufacturing or what have you, but there's not necessarily a platform around plugging those types of companies in. And that's where I think the real value is that you're not going to have one company that solves all your AI problems. You're going to need a level of abstraction depending on what problem you're trying to solve. And so we did what any scrappy 8A company would do. We kind of built our own. And the reason we did is because we wanted to be able to leverage the best of breed in terms of AI and plug into a Watson or Microsoft Lewis type engine and not be constrained. Because AI is definitely evolving, and over the next 12 months, you're going to see kind of exponential kind of improvements in different areas. And so with that, the platform we created was called Chirp, and I'll hand it over to Roseanne to talk about what that platform entails and some of the challenges we had around implementing that.
Hi guys, I'm Roseanne. I'm the product manager working with Team Reva. So like Raj says, our platform is all about customer experience, and we're trying to bring that to the 21st century. So we see a great value in using enterprise data to help customers quickly and intelligently. And on the flip side, the more we know about our users, the more personalized and engaging our ongoing interaction with them can be. So we've created an artificial intelligence-based customer engagement chatbot that uses the best AI technologies, Raj mentioned a couple, to provide a robust conversation solution. So Chirp enables users to take their enterprise data, structured and unstructured, and generate meaningful human-like conversation based on that data. Our platform does that through its patent-pending intent identification methodology. So because we start with the customer's data, the system has use cases across industries. Any federal agency or company that's regularly interfacing with their customers can use Chirp to deepen their customer relationships. One important feature of Chirp is that it is channel agnostic. So we support popular messaging channels like Facebook Messenger, native apps, of course, and even voice-enabled devices like Alexa, which is pretty cool. We want to make it easy for our customers to interact with their customers. So really quickly, we don't have too much time. Let me tell you about a couple of our projects that are going on. We have one that we're working with Children's Hospital out of Miami. We are in early talks with one of our federal partners. One that I want to tell you a little bit more about is with an educational institution that we're working with. They have about 100,000 users hitting their site monthly, asking questions about programs, courses, schedules, things like that. At the start of the project, we received their FAQs and chat logs, and we've now integrated with their live chat system as well. One key component of our system is its natural language querying capability. So when potential students interact with Chirp, they can ask a question in a free text format, doesn't have to be predefined. As you'd expect, many questions are specific to programs of study. So if a user asks, when does the program start? The system would prompt with, which program are you talking about? So by identifying required information like program, the system will automatically interject questions as needed. So the user hadn't indicated which program yet, so we need to interject that question. And then, of course, as the system collects more data, we are using that to iteratively make the system smarter based on user responses and user questions. I don't know how much time I have left. None. Okay.
That's why they call them lightning rounds.
Yeah.
Not thunder rounds here.
That's a little preview of our product.
Awesome. Thank you so much. So how many people in the audience are interested in making customer service better for government? This is just one of the ways, and again, this is such a huge focus, AI for customer service in government. One of you are taking a chair right here. You can choose. All right. So next up, we have Dr. Marilyn Miller, Program Director from the National Institute of Health's National Institute of Aging.
On aging.
On aging.
So this one's going to affect everybody. If you look around the room and look at the people who might be 65, 5% of you have Alzheimer's disease. When you get to 75, it's about 40% of the people in the room. And by 85, it's pushing up towards 70% of the people. This is an epidemic, and the reason it's an epidemic is because we're living longer. We've pushed through some other diseases, found some cures, and now we're living long enough to get Alzheimer's disease. And those genes, we probably all have those Alzheimer's genes, some of them. In 2012, Congress recognized that this was a national problem, an epidemic, and they passed a law called the National Alzheimer's Project Act. That law says that by 2025, we must have a therapeutic target for Alzheimer's disease. And the first milestone in that law is that the genetics have to drive us there by 2020. It's 2017. It's almost 2018. We've got 2 years left. In 2012, the National Institute on Aging launched the Alzheimer's Disease Sequencing Project, ADSP. The project is designed to find risk and protective factor genes for Alzheimer's disease. We're using 2 different kinds of studies, affected versus unaffected individuals and families that are multiply affected by the disease. We're studying multiple ethnic groups. We have 9 work groups in the ADSP. We have more than 100 investigators. We have 10 major institutions, 4 large-scale, federally funded sequencing centers, and the project is both national and international. There are 3 phases to the project: the discovery phase, the extension phase, and the follow-up phase. And each of these has a sequencing phase and an analysis phase. We're wrapping up the discovery phase next year. We're in the middle of the extension phase, and the follow-up phase is being kicked off this week. In our extension phase, where we are right now, we have 4,000 whole genomes. Each of those genomes has 3.3 billion base pairs. And so by 2021, we're going to have 30,000 whole genomes, and each of them still has 3.3 billion base pairs. So the data are big. In terms of NIH, in 2016, we were the 3rd largest data taker of their big databases with 68 terabytes of data. And now, just 1 year later, we have a petabyte of data. That is 1 quadrillion bytes of data just now, and we still have 4 more years of sequencing. I think everybody can understand that the data is very complex to analyze, and it's hard because we don't have any tools out there. We got brave, maybe stupid, but brave, and decided to analyze the whole genomes of all of these people. Other groups for other diseases are taking just the 1% of the genome that looks and makes proteins. We're looking at 100% of the genome. So whole genomes are hard to analyze. And so without tools, it was pretty clear we needed something else if we were going to make this 2020 deadline. And I happen to have been fortunate to have dinner with some folks that I've been working with over the years at NIH, and they told me that they had a project going with IBM Watson, and was I interested? Yeah. By the end of a couple of weeks, we had formulated a hypothesis, which is that machine learning can help us to find the genes that are risk or protective in Alzheimer's disease. We managed to get some money, and now we are in the middle of a project. And the project is they are taking right now as we speak, the 4,000 whole genomes. And two things are happening in the first part. There's a company working with them called Curoverse. Curoverse is able to scrunch up the genomes. That means that we have many regions of the human genome that are all the same in everybody, so we don't need to look at those because those aren't going to be changing, but there are other regions that clearly are changing. Curoverse is flagging those for us. Then they're sending all of those 4,000 flagged genomes over to IBM. IBM is going to line up all the data and look at cases and look at controls, fly above the genome around 30,000 feet, look down to the Grand Canyon and say, oh my gosh, look at chromosome 17 on P23. Something weird's going on there. You guys need to look there. Instead of us going piecemeal, one part of the genome by one part of the genome, they're going to tell us where to look. The second thing that we're doing, and we started this about a month ago, is we have in our basket about 600 genes that we know in some way are associated with Alzheimer's disease. But to us, it's alphabet soup. We don't know how these 600 genes fit together. So we've asked Watson to please look at these genes, tell us what pathways are common, tell us what hubs there are, and tell us if there's something in the way of a therapeutic target in the middle of that hub. What can we do to find the hub? And we're also asking them to look with other diseases. Are there commonalities with other diseases that will lead us to treatments for Alzheimer's disease? And can we now, given the information that we have, with all the pathways and all of the hubs and all of the information from the other diseases that we know that are complex, find a drug that's maybe even already on the shelf to cure Alzheimer's disease?
Thank you so much, Dr. Miller. Round of applause, because I think if there's two things we can be sure that it's exciting that AI could eradicate. One is Alzheimer's disease, two is the show Big Bang Theory, and its terrible spin-off Young Sheldon. If we could only get rid of those things. So next up, again, I'm loving how this is coming together because it's like we're getting a vignette of keynotes here. And again, we're going to have questions and answers after that, so start formulating. But next up, we've got Jordan Higgins, the creative director from ByteCubed. Often Jordan is one of our go-to people in the government for mixed reality, virtual and augmented reality. Now he's here talking about AI. What's going on, Jordan?
Thank you, Justin. Yeah, like Justin said, my name's Jordan. I'm the creative director at ByteCubed. I manage our human-centered design team and also have been working a lot with our mixed reality initiative. We're one of Microsoft's first mixed reality agency partners, where we've been working with them to essentially learn how do we build on our capabilities in data science, custom software engineering, kind of focused on government innovation, and start to apply these new technologies to it. Before joining ByteCubed, I was a federal employee for 10 years. I spent 5 years on Capitol Hill working with Senate offices to use new technologies and social media platforms to engage with their constituents. And then I spent 5 years in the intelligence community. Being less engaged with constituents, I would say, but same sort of thing though. How do we take new technologies and apply them to real world use cases? And with the HoloLens in particular, it's putting digital objects in the world is cool, and immersive environments are cool. But one of the things we kind of quickly realized is that the power of those will be, it's exponentially greater once it taps into systems on the back end that really enhance people's capabilities. Both cognitively and in terms of the world around them, giving them access to just vast amounts of information and learning from them and with them in the tasks that they're doing. But what I wanted to talk about today was something that I've been thinking a lot about as we've been sort of exploring this space and thinking about how people will engage with it. I was watching 2001 and just a curiosity, quick show of hands. How many people have seen the movie 2001 in here? I'm guessing a lot. Cool. Yeah, like I know the HAL 9000 is sort of the low-hanging fruit of it's right up there with Skynet as sort of classic AI examples. But one of the things that really struck me about it was early in the movie how to establish HAL as a character, they emphasize his trustworthiness. That it's never been wrong, and it's completely infallible. And it ties into something that as user experience designers, we really think a lot about, which is how do we establish trust and credibility with our users? And once you've lost that, it's very, very hard to regain that. And it's, more of an existential threat in the private sector, I'd say, in commercial applications, but definitely in government too, particularly when you're dealing with systems that are going to be assisting people with very real concerns, about their health, about their finances, about, their loved ones, things like that. So one of the areas we've been really looking at is bias, not I wouldn't say dangerous, but I say the risks of working with AI really come from this. It's more about bias intruding on the system and affecting the outcomes than it really is anything else right now. And we've been trying to really learn a lot about, try to focus our efforts on where do those opportunities to negatively impact the user experience, to lose that trust, come into play. And there's a lot of great research going on out there right now about this. And what's been interesting for me as a user experience designer is that a lot of the bias factors that we look at when we're normally thinking about human intelligence translate to use cases with artificial intelligence as well. In particular, data set bias is a huge one. This is one where limited models that are used to train a system may cause things to be excluded. This particularly can impact assumptions or predictive models about race and gender and things like that. But other ones too, that where the human element combined with the back-end element. Interaction bias, drawing false conclusions from the input that it's receiving from people, as and in particular, as we're looking at use cases where systems are learning from people as they're interacting with them. But the key takeaway I wanted to put out there today is just that the best way to mitigate bias is to recognize it, is to understand it, and to learn which factors of bias can potentially impact your application or your use case. And would definitely love to follow up and talk to anybody here about applications that they're looking at and where bias may be a factor and how it might be mitigated. And if anybody's interested in mixed reality too, we're always happy to talk about that as well. Thank you.
Thank you so much, Jordan. All right, so next up, we've got Aaron Dane, Chief Data Scientist from ASRC Federal. They are also sponsors today. So an extra round of applause for them. Thank you so much for helping putting this together.
Thanks. All right, so I'm going to start off a little bit differently, since I guess I'm the person up here who focuses on AI specifically. I'm going to talk about fraud, waste, and abuse. This is an area that affects a lot of organizations in the government as well in the commercial industry. ASRC Federal has been focusing on machine learning and artificial intelligence technologies quite a lot over the last couple of years. And one of our recent use cases in earlier this year, we partnered with a commercial healthcare organization. And they had an existing problem they were trying to solve that was related to fraud, waste, and abuse. And fraud, waste, and abuse in the medical industry is huge. It's $88 billion annually. That is larger than the GDP of 2/3 of the world's countries. And a large percentage of that, something like 53 billion, is in prescriptive costs. And a lot of that's the opioid epidemic and similar abuses. So this commercial healthcare provider, they had a belief that they had a big fraud, waste, and abuse problem in their environment. And they had full-time data scientists, and they had applied statistical methods and other traditional data science to the problem. They couldn't narrow down on it. So their hypothesis was that they had a large amount of fraud, waste, and abuse on a particular set of patients that were very, very difficult to narrow in on. And these were polychronic patients, so they had a wide range of diagnoses. They had a huge range of disease conditions, in some cases thousands of unique diagnoses. They had tons of prescriptions. Each one of these people had dozens of prescriptions over a long patient history. And they were all people who were using pain management, massage therapy, and acupuncture services within this healthcare provider. And there was a strong belief that the company was hemorrhaging money due to fraud indicators in this environment, but they couldn't find it. So they turned to ASRC to try to leverage our experience with machine learning and artificial intelligence to track down these hard-to-find indicators of fraud, waste, and abuse. So they set up a pilot program, and they said, we're going to give you our toughest problem. We're going to give you the subset of our toughest people that we can't find fraud, but we know it's there. And so this was hard in a bunch of reasons. One, because these are really complex individuals. How do you classify somebody who has 2,000 diagnoses? If they've got cancer, they have diabetes, they have sinusitis, chronic sinusitis, what are they? Are they a cancer patient? Are they a chronic sinusitis sufferer? How do you classify that person? Also, the data set was very small. For the subset that they wanted us to look at, it was 1,200 users, and it was 4,000 providers. So they gave us this small data set of this tough population, and they said, we don't actually have any tagged data. We don't have any examples where we've positively identified these types of people as committing fraud. That's a big problem for machine learning. A lot of what you hear in the commercial industry for machine learning is, the current rage is in deep neural nets, and it's in supervised learning, where there's human tagging of data, where you know what you're looking for, and you train it to find other things like this. That works great until you don't have any tagged data. My background is heavily in the IC community. It's in federal government. That's what your problem is very often in the federal space. You don't have the same kinds of clean tag data sets that you would otherwise have in the commercial industry. So you're expecting certain levels of performance that you hear Google is doing and Facebook is doing and Microsoft is doing, and then even when those guys get into federal spaces to go play, they don't know what to do because they can't use any of these sort of pre-approved data sets. There's not a good data flow pipeline to tag the data. Fortunately, machine learning is really not a monolithic, it's not a single tool, it's a toolbox. And there's a collection of different opportunities and tools you can take to apply to these types of problems to do more discovery. So we actually built a framework that was based on using several techniques from unsupervised learning, which are algorithms designed to group similar things together without knowing really the context or the content. It's just able to identify similarities and then group them to allow you to do follow-on analysis. So we built a data set that closely resembled the data set of the real users we were given, and those users were thousands of diagnoses, in our case based off of incident rate. And we were able to use manifold learning, an algorithmic way of reducing the dimensions, to create this smaller subset of people that we could then classify together and see who was medically similar to each other. And then use a series of clustering algorithms, and we built a genetic algorithm around it to identify the optimal algorithms from this huge collection to merge the manifold learning output with the clustering output and bring these, this discovery element through using machine learning techniques. The output of it let us do anomaly detection against these similarly identified medical people. So we now have somebody who's a sinusitis sufferer, somebody who has, chronic cancer treatments, somebody who has congenital heart defects, and they're grouped in these spaces according to how medically similar they are, which lets us see whether or not their prescriptive behaviors, whether their claim values, and all of these other things start to add up and make sense. And if they don't, you can raise indicators. And our result from it found in the very, very short period over $250,000 of indicators of fraud for only 8 months of data for that subset.
Thank you so much, Erin. I get intimidated when she raises the card up. It's a stop sign, and there's an exclamation point next to it.
Like,
it's like,
oh, stop.
Holy crap, she means business. I get nervous for a second. Thank you so much, and thank you again for sponsoring us here. We've got one more, and I promise you, because Kenneth is always up to the good business, you should see the proposals that he sends in for what they can be doing. So hopefully he talks a little bit about that. We have Kenneth Walton, architect for the National Capital Planning Commission.
So good morning, everyone. I am an architect at the National Capital Planning Commission, but my focus is really on urban design. So this is really an urban design sort of pitch. And this is a proposed project, not necessarily something that we've already done. And it's called Apprenticeships for American Innovation. So this came out of a co-design
Put the mic a little bit closer to you.
This came out of a co-design session we had a few weeks ago with Justin in the Emerging Technology Group. The administration has created an environment for public and private partnerships. The Department of Commerce selected AT&T to build out a broadband network to help first responders, FirstNet. And so this kind of fiber network is the basis for smart cities. And so our idea combines predictive analytics to match job seekers with training and jobs, and the growth of the smart cities implementation of the Internet of Things as an apparatus to meet two of the Trump administration goals. Apprenticeships for creating job-ready skills, and infrastructure development for job creation and security. So the key objectives of this idea are to use analytics to develop workforce requirements, use existing data sets to baseline smart city infrastructure, and incentivize the development of smart cities workforce. Now, typically, the promise of new jobs diminishes around artificial intelligence, but we believe that new job markets can be built with smart city infrastructure implementation and with job market data sets, and that it's possible to have a net gain of jobs and an increase of income for these workers. Now, this will be done through an apprentice program that would target employment segments of the population that the administration has already identified: returning veterans, women and recent grads, and urban communities. The foundation for this concept came out of an initiative that was created by NIST and US Ignite called the Global Cities Teams Challenge. This initiative created public-private partnerships worldwide to create new common standards for smart cities, sensors, and devices. We worked with the team that kicked off in 2014, and the team contained federal, local, and private and institutional partners, and grew to a large size over that year, gaining partners from each one of those segments. So we had Cisco, we had SenCity, we had the DC government, the federal government, we had George Washington University, and other local business improvement groups involved in that group. Our pilot project, PA 2040, was installed along Pennsylvania Avenue at the end of 2016, and it had a mix of sensors that were mounted to measure a number of different elements and carry out a number of different tasks. And so some of those tasks include public Wi-Fi, transportation, parking, security, visitor experience, which is something that we're really concerned about at NCPC. So here we're talking about immersive VR experience, or AR experiences for the community. We worked with the Park Service and did a co-design session about a couple of months ago where that type of idea was considered for the Lincoln Memorial. We also talked about environment, waste management, water systems, and data management. So all these things are in our existing pilot, which is basically a mesh network with sensors in the street lights along Pennsylvania Avenue between 17th Street and 21st Street and I Street and L Street. And so that's been up for about a year. It's been working pretty good. And so we think it's a good opportunity there to sort of train people to install some of these elements from some of those groups that we mentioned earlier. The potential for growth in smart cities is huge. Experts predict that the market for smart cities technology could reach over $750 billion by 2020. And Cisco has highlighted 15 or 20 projects that will be perfect, jobs that will be perfect for this type of apprentice program. So there's lots of jobs out there, and a lot of those projects were highlighted in our pilot project. So once again, the project here is Apprenticeships for American Innovation, and I'm happy to take any questions you have. Thank you.
All right, thank you so much. All right, I'm gonna take the Pepsi challenge just versus any other government AI event that's been going on. The diverse perspectives we're talking about from design, we're talking about the actual creation of it, we're talking about utilizing, improving customer service, we're talking about helping through medical science, the aging population, and this pitch that he was just talking about was something that we first saw the workshop. So a lot of people don't know, we're in the process right now of establishing the first United States national goals for the implementation of artificial intelligence as well as blockchain, specifically to improve government accountability, transparency, responsiveness, and these things that we call open government. And these will be focused in the 4th U.S. National Action Plan for Open Government. And part of the things that you can go to the atlas we were talking about earlier that Dave from the EPA tweeted out after I said it wasn't ready. That's supposed to be a joke. It's true though, but it's out there, is that we have received dozens, in fact more than 100 ideas like this, again, from all different areas on how the US government can set national goals for artificial intelligence, which will be the first of its kind. These are a discussion happening right now, and if you're passionate about this, if you have a horse in the game, you should be part of that conversation, and the door is open. Now that being said, I promised a good shellacking for the people up on stage. Now, do we have any questions? Quick. Not a single one? No, not even Dan. Dan does not have a question. Awesome. Here we go.
So from the NIH on aging, I'm sorry, I didn't remember your name. Dr. Ruth, was it? Meredith.
Thank you.
So what you're doing is fantastic. I mean, having the whole genome. But to me, it struck me as you were talking, that if you're only using that whole genome to just look at Alzheimer's, you're probably missing a whole bunch of other stuff that you can be doing with it, because, wow, it seems like a national treasure.
Yes. So what we have in our study is controls who have lived through a lot of diseases and don't have them. So our controls are controls for other studies. And there are other studies going on at the National Institutes of Health, also sequencing projects, for example, a large one in stroke and cardiovascular disease. We're using their controls, leveraging them against our controls. And we're also sharing across our various projects. And that's important because we'll have things that are unique to Alzheimer's disease, but I can already see by what IBM Watson has shown us is that there are differences and similarities among the diseases that can be seen in the data that they're generating. And I didn't see that before. I've been doing this for 20 years now, coming up, and none of us in the field who've been intimate with this have seen it. So we are leveraging against each other as much as we possibly can. This is a very important use of the taxpayer dollar. And with any luck, in 10 years, we'll be able to say that this particular person with Alzheimer's disease, personalized medicine, your best course of treatment with your cadre of genes, all being risk factor genes, should go this way in your therapeutic approach. What we believe is that I think we all have Alzheimer's genes, but what we also have are protective genes. And it probably is just as important how many protective genes you have for any one particular disease as how many risk factor genes. Because if you go down one pathway that happens to be having 5 risk factor genes that you happen to have, that may push the domino over. And so if you have an equal number of protective genes, you may not go that way. So that's what we have to find out. We have to find out the likelihood that a person with the protective genes, can we use those protective genes to augment the ability to provide therapy for a subject. And I'll just give you one, sorry to be a stage hogger, but this is really interesting. We're looking at the Medellin cohort, which is a very large sample set, about 1,500 Colombians. And they have very large multiplex families. There are many families that have 20 individuals in them. And they have the same mutation. But with the same mutation, some people get the disease at 30, and some people don't get it till 70. So some of those people have protective genes. We have to find those protective genes.
Thank you so much. And actually, I'm going to NIH tomorrow. NIH is having an AI forum tomorrow discussion. So perhaps I'll see you there. Oh, we've got a hand. Oh, 5 more minutes. All right. Who else has got a question for anybody else on the panel? Before I ask a question then. All right. So quick question again. Completely different skill sets, perspectives, organizations. Each of you you wanted to be up here to talk about something you're passionate about very succinctly, which is very hard in the AI community, succinctly. What's the missing gap? Like, what's something that what you see is possible, what we must have in the near term, but there's obviously a gap. There's a reason that we're talking about it and not that it's not already here today. And so there's no particular order, just go with it. What is a gap? Because maybe there's somebody in the room or there's something that ACT-IACT can do together that we can start filling those gaps. What do you
Yeah, absolutely. I think that AI is in a really weird place right now. with a lot
So
of
it's
other
weird. The whole damn thing is weird
Well,
sometimes.
it's particularly weird in that, with a lot of up and coming technologies, when the cloud became the big thing and everyone was like, oh, we got to get to the cloud is going to change everything, and we're going to get these big streams of data and it's going to be this big thing. That progressed very, very quickly from a research notion to something that was product oriented, that you had sort of your standard working class engineers who were able to pick up the capabilities from the research community and implement it in production for federal spaces and commercial spaces very quickly. The ramp up time from the earliest big table implementations to everybody in a federal space has a cloud engineering team. Everybody writes MapReduce or Spark or whatever, and it's been productized in a way that people who aren't researchers, who are not in the community of academia or working for one of like the 3 biggest commercial companies in AI, were able to develop something in these proven spaces really early on.
Yeah.
AI is not that way. AI is totally Mad Max right now. It's everybody's on their own little crazy cart driving around in the desert, trying to figure out what direction things are going to go. There's no productized framework that's just the solution for AI that everybody uses. And that's the biggest gap. And where you're going to see these gains is there's this handful of people, and you see them up here as the keynote, the handful of companies who are pushing forward that gap to try to get to the point where there is a productized capability that you can bring to a system and say, look, this has been proven, you deploy this thing and it works, and you can train your people to use it. You don't have to have a team full of PhDs to implement it. And there's just a big gap right there.
It's exactly like one of the big things that we talk about within the federal community, especially when the doors are closed or it's after hours at a bar. That's also a nice meetup to talk about AI, is that there's the democratization of the technology. For so long, government has been in AI for decades, in research and development shops and labs and all this behind the scenes, where now, because of advances in the availability of government data and processing power from chips and systems, things that before were just in research and development are potentially in the hands of any program. And I like Mad Max better than the Wild West, but that's why we have to have these conversations. That's why you're hearing so much about it. All right, so because we have less than 5 minutes, so